Hello, this is Math 18, Section 2.6. Today we're looking at an introduction to equations. So we have two objectives today: to determine whether a given number is a solution to an equation, and then to actually solve an equation that's in the form x plus a equals b. So let's get started. So first of all, you need to know a couple of definitions. An equation just shows the equality of two mathematical expressions. The expressions can be either numbers, numerical, or variable expressions. Okay, so an example of an equation would be something like x plus 5 equals 7. That's an equation. And the difference between an expression and an equation is very important. An expression does not have an equal sign, and it only has just terms, written together with plus or minus signs. An equation always has an equal sign. That's the difference. An equation will always have an equal sign, and it will have a solution. So the solution is the number that when you plug it in for the variable, it gives you a true statement. So if you look at the equation I've written up above, x plus 5 equals 7, the solution would be 2, because if you plug in 2 where the x is, you would get a true statement. So this is the first thing that we're going to look at, is telling whether a number is a solution or not. So look at the examples we have here down below. 5 is a solution of the equation x plus 8 equals 13, because if you plug 5 in where the x is, 5 plus 8 equals 13. That's a true statement. 7 is not a solution, because if you plug it in for x into the same equation, 7 plus 8, that equals 15, and that does not equal 13. So if you were asked if 7 is a solution or not, the answer would be no. Okay, so the important thing to see here is that when you have an equation, you always have an equal sign, and that the answer to an equation is a solution. That's the number that makes it true. So to determine whether a number is a solution or not, here are the steps that you're going to go through. You're going to substitute the variable with the given value. Like we will ask you, is 3 a solution of this equation? So everywhere there's a variable, you're going to plug in a 3. So it's similar to what we did earlier when we were evaluating variable expressions. We're plugging the number in for the variables. Make sure you put the value in parentheses, and then the one difference here is that you'll have two separate sides of the equation, and you'll simplify each side to see if you get a true statement at the bottom, like 5 equals 5. Then that would be yes. The answer, the solution is the number is a solution. If you get a false statement like 5 equals 4, then the answer is no. The number is not a solution. So that's what we're going to be doing. So look at this first question. Is 2 a solution of 7 minus 3n equals 2? So what you're going to do is you're going to plug in the 2 everywhere there's a variable, in this case the n. So we're going to have 7 minus 3 times 2, because that's what that multiplication is there, 3n. 3 times 2 equals 2. So the right-hand side of the equal sign is already simplified to just a number 2. But we have to simplify the left-hand side. So we're going to do multiplication first and follow the order of operations. So we have 7 minus 6, okay, equals 2. Well, 7 minus 6 is 1, and that does not equal 2. So the answer is no. Okay? Now, the second one is 4, a solution of 3y minus 4 equals 2y. The main difference here is that you've got variables in two different places. So you're going to plug in 4 everywhere there's a y. So we're going to have 3 times 4 minus 4, and we want to know if it's equal to 2 times 4. So the 4 goes everywhere that you have a variable. Okay? So let's look starting on the left side. 3 times 4 is 12 minus 4, and then if we work on the right side, 2 times 4 is 8. So now finishing up the left side, 12 minus 4 is 8, and that equals 8, so the answer is yes. Okay? So here's a couple more. You can either try these on your own, pause the video and try them if you want, or you can just work along with me, either way. So, is 3 a solution of z squared plus 1 equals 4 plus 3z? So we're going to plug in 3 everywhere there's a z in this case. Now be careful, that first part with the square, make sure you put that 3 in parentheses. 3 squared plus 1 equals 4 plus 3 times 3. So on the left side, we're going to start with our exponent. 3 squared, 3 times 3 is 9 plus 1. And then over here, 4 comes down, and we're going to multiply. 3 times 3 is 9. So 9 plus 1 is 10, and that's not going to be equal to 4 plus 9, which is 13. So the answer is no. Now, the last one here, we want to know, is negative 2 a solution of 2x plus 5 equals x squared minus 3? Especially when you have a negative number that you're plugging in, make sure that you put that number in parentheses. So we're going to have 2 times negative 2 plus 5 equals, make sure that negative 2 is in parentheses, negative 2 squared minus 3. Okay, so on the left side, 2 times negative 2 is negative 4 plus 5. So if we want to go ahead and work that out, that would just be positive 1, because you would subtract and keep the sign of the larger number. On the other side, if we do our exponent first, that's negative 2 times negative 2, which is 4 minus 3, so that's positive 4, and 4 minus 3 is 1. So we have a true statement, so the answer is yes. So yeah, you have a 50-50 chance of getting these right, but you don't want to guess in math. There's no guessing in math. It's scary if you do that. Only if it's multiple choice and you have no clue. Then you can guess. But other than that, you want to work it out, okay? All right, so now we're going to actually look at solving equations. So the rest of this chapter is going to be very much built on this section and the next section with the basic steps of solving equations, so that when you get to really long equations and you can't just look at it and tell what the answer is, you'll still be able to get the answer by knowing these basic steps. So the first equation that we're going to look at solving is going to be in this form: x plus a equals b. Now, a and b are going to be numbers, okay? And so to solve the equation means to find the solution. And the equation that we want to get it down to is a variable equal to a constant. So if you have something like x equals 3, that is what we're looking for, is to get the x all by itself, get the x isolated, and equal to just a number on the other side. Now, technically, x equals 3 is an equation, just like down here, x equals 5. The solution to that equation is 5, or the solution to our equation is 3. You don't have to write out 3 as the solution, because if you get down to x equals 3, you and I both know, okay, the answer is 3. Move on. Nothing to see here, okay? But technically, those are equations, okay? So all of these equations below are called equivalent equations because they all have the same solution. X plus 2 equals 9, x plus 6 equals 13, and x minus 3 equals 4 all have 7 as their solutions. But the main thing that we're going to be doing is trying to get it down to that variable equals a constant. That's our main goal on solving all of these equations. So to do this, to get these variables, the x all by itself, we're going to use the addition property of equality. So this is not a property that you need to memorize its name, but you need to know how to use it. So basically what this says, think about your equations like a scale, okay? And you have the left side of your scale and the right side, and in the middle, what keeps it balanced is your equal sign, okay? So what the addition property says is that you can add the same thing to both sides and it will not change your solution. That also applies to subtraction. But if you do that to one side, you have to do the exact same thing to the other side. That's what keeps that equation or your scale balanced. That's the main thing. So if you add 5 on the left, you better add 5 on the right. Okay? That's the key. So that's what the addition property of equality tells you. So what we're going to be doing is we're going to remove the term from one side of the equation by using the opposite. So in other words, if you have x plus a equals b, okay, a and b are going to be numbers. You want to get rid of this a so that the x is all by itself. So we're going to use the opposite. We're going to subtract a from both sides. So the x is going to come down, and the key here is that those a's are going to cancel. And then over here, this will be two numbers, okay? So you would just subtract when you get to that other side. Two numbers, so you would subtract. And that would give you your final answer. Okay, so you can't really write b, we don't want to write b minus a there, that'll freak you out. But you'll get a number there, okay, when you subtract. That's the whole idea. So look at this first equation. X minus 4 equals 2. I know a lot of you can guess at what the answer is, and you're like, why do I need to go through all the steps? If you don't know the baby steps and the beginning steps, you'll never be able to do a longer equation. So you need to write these basic steps out and get in the habit of knowing what to do at each step of the equation. So we have x minus 4 equals 2. We're trying to get x all by itself. So you look and say, okay, what's on the same side of the equal sign with the x? That negative 4. So to get rid of a negative 4, we have to do the opposite. We're going to add 4 to both sides of the equal sign, underneath both sides, okay? And then draw a line. Now, the x comes down. It is worth it, and you better do this to make sure, to take your time and say, okay, negative 4 and positive 4, those cancel. It is worth the, 2 seconds of your life to make sure that those work and that those do cancel to 0. If they don't, you're doing the wrong thing. So that's how you know if you're on the right track or not. Okay? So x comes down and the equal sign, and on the other side, 2 plus 4 would just be 6. So we've solved it. Now, let me show you how to check it. I'm not going to check them all because you'll go crazy, and so will I. So, but it's good to know how to check, because on a test, you always have time to go back and check your answers, and you can make sure that you've got the right solution. So to check it, we're going to take our answer 6, and we're going to plug it back into the original equation. So 6 goes in for x, and so 6 minus 4 is 2, and that equals 2, so it checks out. So that's how you check your solution, is you plug your answer back into the x. Okay? Let's look at number 2. Y plus 5 equals negative 5. So y is our variable, which means we're trying to get rid of that 5 that's on the same side with the y. So since it's a positive 5, we're going to use a negative 5. So we put minus 5 on both sides. The y comes down. The 5's cancel. Now over here, a lot of people go, oh, those cancel too. But look at your signs, negative 5 and negative 5. Think back to chapter 1. If the signs are the same, you add and keep the sign. So that's going to be a negative 10. Okay? So be careful there. A lot of people will subtract 5 on both sides, and because they still don't know their sign rules from chapter 1, they get the answer wrong. So be very careful about, working out the side where you're actually doing some computation there. Now, look at number 3. Negative 9 equals n plus 1. So the variable's on the right-hand side of the equation, and a lot of students really dislike this. To me, just work it the way it is. It's not that big a deal. Okay? You're trying to get the n all by itself, so we want to get rid of that 1. That's what's on the same side of the equal sign. So since it's plus 1, we're going to subtract 1 from both sides. Subtract 1. Now on the left, I have negative 9 and negative 1. Their signs are the same, so we add and keep the sign. And that bothers a lot of people. They're like, but there's not even a plus sign there. But you're still using your addition and subtraction rules. So the addition rules say if the signs are the same, add and keep the sign. So we're going to get negative 10 equals n comes down and the 1's cancel. Okay? So here's some more. Number 4, 7 plus x equals 11. So look at what's on the same side of the equal sign with the x. We have a 7 there, okay? So that's what we want to get rid of. Now, that is a positive 7, so I'm going to use a negative 7, or subtraction for addition. Okay, so we're going to subtract 7 from both sides. Well, 7 minus 7 cancels out, and x equals 11 minus 7 would just be 4. Okay? And now look at number 5. 14 equals 6 plus w. So we need to look up where the w is, okay? And now we want to get rid of that 6. It's a positive 6, so I have to subtract 6 from both sides. Okay, make sure you do it on the other side of the equal sign, keeping that equation balanced. So 14 minus 6 is 8. Just subtract there. The 6's do cancel, and we bring down the w. Okay, so whenever you're doing these problems, always focus on where is my variable first. That's what you need to see, is where do I have the variables, what do I need to do to get that variable all by itself. That's the main thing. Look at number 6. We have 3 equals negative 11 plus b. So my variable is b. I want to get rid of the number on the same side, the negative 11. Since it's a negative 11, I'm going to do the opposite. I'm going to add 11 to both sides of the equal sign. Okay? So 3 plus 11 gives me 14. The 11's do cancel, and we bring down b. Okay? So now here's some for you to try. So pause the video. This section and the next section are probably the two sections that we're going to use, that and the sign rules from chapter 1 throughout the rest of the course. It's going to be so important to be able to do these basic equations. Alright, so pause the video and try these. So here's number 1. Negative 5 equals negative 3 plus x. The number that's on the same side with the x is the negative 3. So I need to get rid of it by adding 3 to both sides. I'm going to add 3. So negative 5 plus 3, you have to subtract there. You get negative 2 equals, the 3's cancel, and we just have x. Okay, so x is negative 2. Number 2, m plus 14 equals 9. The m is our variable, so the number that's on the same side is positive 14, so we're going to subtract to get rid of that 14, minus 14 on both sides of the equal sign. So the m comes down, your 14's cancel, and 9 and negative 14 would be negative 5. Because remember, you have to subtract and keep the sign. Is that right? 14 minus 9? Yeah. I'm having brain fart. Sorry about that. Okay, so you would subtract and keep the sign of the bigger number. Okay? Look at number 3. X minus 7 equals negative 4. So the variable is x. Negative 7 is on the same side, so we're going to add to get rid of that 7 and add 7 on the other side. Okay, so the x comes down. The negative 7 and positive 7 cancel. And we have negative 4 plus 7. You're going to have to subtract there, and that would give you positive 3. Okay, so here's some more. Number 4, y minus 10 equals 32. So the y is your variable. The number that's on the same side is negative 10, so we're going to add 10 to both sides. Okay, so y comes down. The 10's do cancel. And 32 plus 10 would be 42. Okay? On number 5, we have negative 1 equals negative 22 plus z. So z is my variable. We're trying to get rid of that negative 22 that's on the same side with our variable. So we're going to add it. Do the opposite. Okay? Add 22 to both sides. So negative 1 plus 22, we have to subtract there and get positive 21. The 22's cancel, and the z comes down. Okay? And number 6, 36 equals 59 plus n, positive 59. So the n is our variable. We need to get rid of the 59. So since it's positive, I'm going to use a negative 59. So I'm going to subtract 59 on both sides. So it's hard to subtract upside down. Let's see, we'd get 23, and it would be negative because the 59 is larger and it's a negative. So the 59's over here cancel, and we have n. So n equals negative 23. Alright, so the main thing you need to see here, I think we're almost to the end, is that if you have addition between the number you're trying to get rid of and the variable, you're going to need to use subtraction. Or if you have subtraction, you need to use addition. Or if it's a negative, you need to use a positive. It's always going to be the opposite sign when you're dealing with addition types of equations. Alright, so it looks like we've got some more. Negative 9 plus w equals 33. So the w is what we're trying to get by itself. So we're trying to get rid of that negative 9. So since it's a negative, we're going to add 9 to both sides. So the 9's cancel, and W equals 42. We just add 33 and 9. Okay? Number 8, we have 5 plus x equals negative 7. So we're going to look at the x, and we see the 5 on the same side. That is a positive 5, so I have to subtract 5. Use the opposite from both sides. So 5 and negative 5, those do cancel. I have x equals, and negative 7 and negative 5 we add, keep the sign, x equals negative 12. Okay? X minus 17 equals negative 2, that's number 9. And so here the x is our variable. So the term that's on the same side with it, that number is negative 17. So I have to use a positive 17 on both sides. The x comes down. The 17's do cancel. And negative 2 plus 17, you're going to subtract there and get positive 15. And that should be it for 2.6. Yep.